Hello students, today we will see cutoff wavelength and cutoff frequency of waveguides. So in this lectures, first I will draw the rectangular waveguides. This is a rectangular waveguides. So this dimension is A and the height will be represented by B. Okay, the so width is A and the height is B. So some waves are traveling inside this one. So there are different modes are there, TE mode and TM modes. Okay, so we will call this one as MN. N modes are there. Okay, so for example, if it will be TE10 modes, so M equal to 1 and N equal to what? 0. For example, TM11, so for this one M equal to 1 and N equal to 1. Okay, so just remember this. So we have to find out the cutoff wavelength and the cutoff frequency inside this particular waveguides. So firstly, I will write down the formula for cutoff wavelength. So cutoff wavelength, that should be represented by lambda 0 equal to 2a divided by m. Okay, so this is nothing but what the width or the distance between the walls are there. So the formula for E equal to what? M lambda n divided by 2. So this is a waveguides. Okay, so distance between the wall is E. Okay, so E is what? The distance between walls. Okay, then lambda n equal to wavelength in direction to the normal to the both the walls. So wavelength in normal to both walls. Okay, so wavelength for both the walls. So lambda 0 is a cutoff wavelength. Similarly, M and N, that is the number of half wavelength of electric intensity to be established between the walls. Okay, so if here for T11 modes M equal to 1, so this M equal to 1 I will put it, so lambda 0 equal to what? 2a. Just remember, so cutoff wavelength that should be equal to twice of a distance between the walls are there. So this is the formula for cutoff wavelength. Now we will go for the cutoff frequency of waveguides. So here cutoff frequency of waveguides. So in this one, this cutoff frequency equal to 1.5 into 10 raised to 8 under root of m by a bracket square divided by n by b bracket square. Just remember, on this particular cutoff frequency of waveguides, on this particular what we'll say topic, we have the numericals. So cutoff frequency fc equal to 1.5 into 10 raised to 8 under root of m by a square plus n by b square. Okay, so fc is basically what? Cutoff frequency. B is the height. So for example, This is a rectangular waveguides. So distance between this will be A and the height will be represented by B. Okay, and here some waves are traveling TE11. So here M equal to 1, N equal to what? 1. So we have to put this in formula. Fc equal to 1.5 into 10 raised to 8 under root of 1 divided by A square plus 1 divided by B square. Like this one, you should add it. Okay, so you have to remember this formula, and we have to solve one problem on this one, or 2-3 problems on this one. So problem I have to share with you. Here I have to read the problems. You just go through the notes, class notes, where you will get all the solutions and all this. Okay, a rectangular waveguide. Here the rectangular waveguides is there. Here problem first. This is Z, X, Y. So this is a rectangular waveguides. With a cross section of 5 centimeter into 2 centimeter. This is the cross sections of 5 centimeter into 2 centimeter, which will propagate at TM11 mode at a frequency of 10 gigahertz. At a frequency of what? We'll say 10 gigahertz. So find out cutoff frequency. So here so just remember, you have to find out the cutoff frequency. So FC equal to the formula is 1.5 into 10 raised to 8 under root of m by a square plus n by b square. Okay, so a value is 5 centimeter and the b value is 2 centimeter. Okay, and here t m11, so m equal to 1, n equal to 1 is there. So cutoff frequency, we have to find out the cutoff frequency. Fc equal to 1.5 into 10 raised to 8 under root of 1 divided by e, that should be in centimeters. So we have to convert this in, or you should write down in centimeter also. So firstly I will convert this in mm. So 5 into 10 raised to 3 square plus 1 divided by n. N is 1, b value is 2 centimeter, so a into b. So 2 centimeter means 2 into 10 raised to minus 3 square. So just find out, we will get the value in terms of hertz, and you should write down the answer. You should write down the answer in a Google Classroom. Okay, similarly we will go for the next problem. Here a rectangular waveguide which has a cross section of 5.1 centimeter into 2.4 centimeter. Calculate the cutoff frequency for dominant mode that is T10 modes. Okay, so just remember here we have to find out cutoff frequency. M equal to 1, N equal to 0, A equal to 5.1 into 10 raised to minus 3, that is 0.0051. Then B equal to 2.4 into 10 raised to minus 3, that is 0.0 0.024. Here one. So just put the value Fc equal to what? 1.5 into 10 raised to 8 under root of m by a square plus n by b square. So put the value 1.5 into 10 raised to 8 under root of m. Okay, just put this value, that is 5.1 into 10 raised to minus 3 e, sorry, m is 1, e is 5.1 into 10 raised to minus 3. So this is bracket square. Okay, plus n is 0 divided by b. B is 2.4 into 10 raised to minus 3. So this will be 0. So only you should find out this value. You will get the value of cutoff frequency. You just put the answer in Google Classroom. Okay, thank you.